Hello student, I am your favorite mathematics teacher Swapnil Sir and I am welcoming you all back to yet another video on our channel. Already we have started lecture series based on the different topic from SPI. As the SPI exam is coming closer, we have to go for important example and important topic for our today's lecture. Okay, so in our today's lecture I'm going to explain to you all first of all some of the basic concept related to trigonometric, and at the end we go for solving some of the example. Okay, as we know that based on the SPI question paper, as I have observed, there are near about 20 to 18 to 20 questions I found in your SPI question. Okay, so we're gonna see everything in our today's lecture. So without further ado, let's get dive into our today's lecture. First of all, we're gonna see what actually some of the terminology there in a trigonometry, and at the end we go for solving some of the examples. So without further ado, let's get dive into our today's lecture. So this is our today's lecture, completely based on the SPI trigonometric syllabus. Okay, yes. Actually, we all are familiar with the trigonometric word and actual meaning of that word. Okay, so trigonometric word is built from the trigonometron. That means measurement of 3 sides and 3 angle. Where we consider it as the trigonometry. Okay, yes. So what actually we are going to learn in our trigonometry? In our trigonometry, we are going to learn all different ratios like sine, cosine, tangent, cotangent, secant, cosecant. All these trigonometric ratio we are going to learn in our today's lecture. Okay, so all these trigonometric ratio we are going to understand using some figures. Like we are going to consider here first of all a right angle triangle. With considering one of the angle, we go for finding the all these ratios, and at the end we go for solving some of the example based on the all these syllabus. Okay, so I'm expecting that you all are excited to see my today's lecture. So let's get started our today's part. Okay, yes. So here in our trigonometry, we generally deal 3 angles and 3 sides of a triangle. Okay, now see that here I do have a triangle. Let me plot the triangle right now. Okay, let me change the color. Okay, yes, I do have triangle. Okay, you may consider this triangle. Okay, yes. Let me go for another color, just that you can understand. Let me plot one triangle here, triangle A, triangle B, and triangle C. Okay, so I do have 3 triangle, triangle A, triangle B, and triangle C. So within the 3 I do have 3 vertices. Okay, I just have some of the errors here. Okay, so I do have 3 vertices here. Vertices A, vertices B, and vertices C. As we can see, this one is our right angle triangle. So if you do have like obtuse angle triangle, acute angle triangle, first of all you have to convert it into the right angle triangle, plot the height where you get this triangle in the form of a right angle triangle, and then proceed further for your next calculations. Okay, so actually I do have right angle triangle already here. Which one of the angle we know that it is a 90 degree. Okay, so this one is the right angle. This one is a right angle triangle. Okay, one of the angle it is a 90 degree here. Remaining 2 angle we don't know. Okay, but there sum it is a 90 degree. As we know that the sum of all angle of a triangle which is a 90 degree. That's why when it goes to 90, remaining their sum it goes to 90. Okay, now think about angle and angle A and angle C. So if we do have to deal angle A and angle C, in such a case we are going to use some trigonometric ratios that I already earlier explained: sine, cosine, tangent, cotangent, secant, cosecant. Okay, all these ratios we are going to understand it here with the angle A and angle C. Okay, now see that I do have angle C. Okay, let's consider about angle C. Okay, I don't know the angle C and I have to go for some of the operation based on the angle C. So what we do, we are going to apply some of the trigonometric ratio, sine, cosine, all these ratio with respect to angle C. Okay, So let me define here first of all about angle C. Okay, about angle C we write sine, cosine, tangent, cotangent, secant, cosecant. Okay, first of all let me define sine. About this angle C, okay, sine of angle C. Now we can see that we have three vertices, that one of the vertices C here that we don't know the value. So we are going to define all the trigonometric ratio with angle C. So we have to find out the sine of angle C. Now as we know that one of the biggest side in our triangle, it always represent hypotenuse. One of the biggest side from our triangle, it is a hypotenuse. So front side of an angle C, which is a opposite side, front side of angle C, which is opposite side, remaining side here in our angle triangle, which is the adjacent side. Okay, which is the adjacent side. Okay, one of the biggest side, which is a hypotenuse side. Big remaining front side we have opposite side, and the remaining side which is the adjacent side. Okay, always remember that. How can we find out the adjacent and opposite? Most of the student, as I have found, they are confused with the opposite side and adjacent side. Okay, but as I know that if you're going to understand in actually the meaning of this word, you can remember it for long. Okay, so biggest side, always remember that it is a hypotenuse. Front side of angle C, front side of angle C, we denote it as the, or we write it as the opposite side, and the remaining third side give it is to the adjacent side. Okay, so adjacent, opposite, and hypotenuse. I do have three sides here. Now I have to go for the sine of angle C, sine of the angle C. Now about sine of angle C, we know that sine of angle C which represent opposite side divided by hypotenuse. Okay, we write it as the opposite opposite side divided by hypotenuse, we write it as the sine of angle C. Okay, so here sine of this angle, we write a opposite side divided by hypotenuse. That means the measurement from side AB to measurement from side AC. Okay, so we write it as the AB divided by opposite side, it is AB, and hypotenuse we have AC here. About the sine of angle C, let's define cosine of angle C. Okay, let's define cosine of angle C, which is a cos of angle C. So cos of angle C, we define it as the now we have given opposite side for sine. The remaining side other than hypotenuse, we go for it the cos of angle C. Okay, so adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. Okay, cos of angle C. Similarly, you can go for the tan of angle C. That means we know that tan can be written as tan theta, or tan x can be written as sin x upon cos x. Okay, so tan x can be written as sin x upon cos x. Okay, it is the actual meaning of a tan x. Or you can define tan x by using that figure directly. Tan x can be defined as opposite side upon adjacent side directly. Okay, okay, or you may write sine of angle C upon cos of angle C, which is this divided by this. So base can be cancelled here. So we left here with the opposite side upon adjacent side, which can be defined as a tan of angle C. Okay, so this is the way that we can find out the sine of angle C, cos of angle C, and tan of angle C. Okay, similarly we have to deal another ratio too. Okay, cosec, sec, and cot. Okay, let me explain cosec, sec, cot in just a moment. Okay, cosec of angle C. Okay, we know that cosec of angle C can be written as 1 upon the sine of angle C. Okay, sine and cosec, they are the inverse ratio of each other, that we can use this concept here. Cosec of angle C. After that, cot of angle C can be written as 1 upon tan of angle C. After that, sec of angle C, sec left here, sec of angle C can be written as 1 upon cos of angle C. Now see that these are the actual inverse ratio of each other. So if you are good with the sine, cos and tan, if you are good with the three of these trigonometric ratios, then easily you can define cosec of angle C, cot of angle C and sec of angle C. Okay, that's it here, that you need to understand only the value for cosec, cot, sec or sine, tan, cos. Okay, yes, that we know that. We know that sine of angle C can be defined as opposite side of angle C divided by hypotenuse of angle C. Okay, so that means we write cosec as hypotenuse of angle C divided by hypotenuse of angle C divided by opposite of angle C. That I just returned denominator as a numerator and numerator as a denominator as a part of our calculation. Okay, that we know that 1 upon A divided by B can be written as B divided by A. That ratio I used it here. Okay, yes, 1 upon tan of angle C, we know that tan of angle C can be written as opposite side, opposite of angle C upon adjacent of angle C. So we write adjacent of angle C divided by opposite of angle C. Okay, which is the cot of angle C, and sec of angle C can be written as 1 upon cos of angle C, and we know that the cos of angle C, which can be defined as adjacent side of angle C divided by hypotenuse of angle C, and it is the inverse ratio here. So we write hypotenuse of angle C divided by okay, this is the way that we can define all the trigonometric ratios here. Okay, so after that there are some another values that we can define here. Okay, that the value for sine, cos and cosec, sec, cot related to 0 degree, 30, 45, 60, 90, 180, 270, 360. Okay, like a 0, pi by 6, pi by 4, pi by 3, pi by 2, 3 pi by 4 and 2 pi. Okay, all these values are very much important here. So all the values we start from the 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, 270 degree, 360 degree. Okay, these are all the value that we are going to learn with respect to sine, cos, tan, cosec, sec, cot. Okay, 0 degree means we write it as the in the form of a radian, 0 as it is. Okay, 30 degree can be written as a pi by 6. Okay, pi by 6 radian. 45 degree can be written as a pi by 4. 60 degree can be written as a pi by 3. 90 degree can be written as a pi by 2. 180 degree can be written as a pi. 273 pi by, let me write 3 pi by 4. And here 360 degree can be written as 2 pi. Okay, these all are the value that we need to understand it here. Okay, that we are going to learn with respect to sine, cos, tan, cosec, sec, cot. Okay, all the values that we are going to learn under sine, cos, tan, cosec, sec, cot. Okay, sine, and we know that sine 0 always 0. Sine 30 which gives us 1 by 2. Sine 45 1 by root 2. Sine 60 root 3 by 2. Sine 90 1. Sine 180 0. Sine 270 minus 1, 360 0. Okay, all these value related to the sine you all have to understand. Okay, similarly for cos of a 0 we know that 1. Cos pi by cos 30 or pi by 6 we know that root 3 by 2. Cos 45 degree we know that 1 by root 2. Cos 60 degree we write it as the 1 by 2. Cos 90 degree which is a pi by 2. Cos 90 degree we know that which is a 0. cos 180 degree which gives us the -1, 270 degree 0, 360 degree which gives us the 1. Okay. Similarly, we can define for tan. Similarly, we can define here for tan of all angle. Okay. So I define here for sine cos. Similarly, you can do for the tan. Tan of a 0 degree, we know that tan 0, 0. Okay. Sine of tan of a 30, tan of pi by 6, we know that, which is the 1 by root 3. Okay. Yes. And after that, tan 45, 1. After that, tan 60, we write it as the root 3. Okay. After that, tan 90, we cannot define it is a 0 because that goes to the infinite value. Okay. And tan 180 is 0. It is a infinity. Tan 3 pi by 4, 3 pi by 2 infinity. Okay. And tan 360, which is again 0. Okay. These all are the value for tan. Similarly, you can define for cosec, sec and cot. All these are the very easy value that you can define it easily. Okay. And if you found it is difficult to remember the value, then let me know in my comment section. I will come up with some separate videos that you can understand all these concepts. Okay. Yes. Let's move for the some of the example based on the today's concept that we have learned it here. Okay. That the concept we learn it here, we are going to understand it here today. Okay. Okay. Let's get start our today's lecture with first example. We have given triangle ABC. It is a right angle triangle. Now let me plot the triangle whose one angle is a right angle triangle. Okay. Okay, let me plot one right angle triangle. Okay. Okay, we can consider this one is the right angle triangle. Consider triangle A, B and C. Triangle ABC, it is a right angle triangle we have given. Okay. And next condition we have angle B, which is a right angle triangle. I already plot that angle here, which is a right angle triangle. Length of a side AB, which given here 24 centimeter. Length of a side AB, which given 24 centimeter. Length of a side BC, which given 7 centimeter. And we have to find out the value for sine of angle A, cos of angle A, sine of angle C and cos of angle C. Okay. Yes, as we know that we have angle ABC, which is a right angle triangle. Side AB given, side BC given, we need a side AC. As we are dealing the value of a sine of angle A, which contain hypotenuse, like a opposite side upon hypotenuse. But as we don't have the value for hypotenuse, first of all, we have to work for the hypotenuse. Okay. Let's find out the value for hypotenuse and then we'll proceed with the value for sine and cos with angle A and angle C. Okay. Yes. Let's get start the solution. I'll explain to you all first of all what actually the value for side AC. How can we find out the value of side AC? As we have right angle triangle, we know that we can apply directly Pythagoras theorem in order to find out the value for hypotenuse. Okay. So as we have side AC, we can write it as the by using Pythagoras theorem. Okay. By using I'm writing it into the short form. Okay, by using Pythagoras theorem, we can write a right angle triangle as a hypotenuse square, which is equal to addition for remaining two side square. Okay, addition for remaining two side square. This one is the basically Pythagoras theorem we do have. So that means AC square, we can write it as the AB square. AC square, we can write it as the AB square plus BC square. Okay, this is the actually our Pythagoras theorem. That we know that the AB square we have given 24 square plus BC square we have here 7 square. That gives us the value for AC square here. Okay. Yes. So we have to find out the 24 square plus 7 square. Okay. So 7 square we know that the 49, 25 square is 625. So 24 square which goes to smaller than 25. Okay, let me find it here. Okay, which is a 576. Okay, which is a 576 plus 7 square, which is a 49. Okay, if you are going to add this one here, so we get the 525 maybe. Okay, which is after that 5 5 4 9 9 15. Okay, 6 25. Okay, okay, we get it is the 625 maybe. Okay, 4 9, which is a 625. Okay, so that we can write it as a 625. Okay, 49 plus 6 576, which is a 9 and 10 15, 9 and 15 15, one up there. Okay, 1 as 8 and 4 12. Okay, and one up there 625. Okay, so we got the AC square, which is a 625. Okay, that you can find out the value by using Pythagoras theorem. AC square is a 625, but as we want the value for only AC, not AC square. Okay, as we want the hypotenuse AC, so AC can be written as 25. Okay, AC can be written as a 25 centimeter, because we know that 625, it is having perfect square root, which is the 25. So we have the value for hypotenuse AC, which is the 25 centimeter. Okay, hypotenuse AC, which is a 25 centimeter. So three sides, so we have sides AB 24 centimeter, side BC 7 centimeter, side AC 25 centimeter. Okay, we have three of these sides present here. Okay, by using three of these sides, let's define the values for sine of angle A, cos of angle A, sine of angle C, cos of angle C. Okay, yes. Now about sine of angle A, we write here sine of angle A. Okay, sine of angle A, we write opposite side BC divided by hypotenuse AB, AC, divided by hypotenuse AC. Okay, and the value for BC, we have 7 centimeter, divided by value for AC, which is a 25 centimeter. Okay, so actually the value of a sine of angle A, we write as 7 by 25. Similarly, we write a sine of angle C. Okay, let me find out only about angle A. So cos of angle A, we can write it as the opposite side upon cos of angle A. Okay, about the cos of angle A, we write the adjacent side AB divided by hypotenuse AC. So AB, which is written as 24 centimeter. Okay, 24 centimeter divided by 25 centimeter. This one is the value for cos of angle A. Okay, similarly define the value for sine of angle C and cos of angle C. Keep this part for your homework and tell me the answer for what is the actual value for cos of angle C and sine of angle C. Okay, tell me the value for cos of angle C and sine of angle C in my comment section. I'm waiting for the solution of this question. Okay, and if you found anything difficult, let me know in my comment section too. I will come up with a similar video like these ones. Okay, now let's move for the next question. I'm expecting that you will have understood this solution. Okay, we have given in our next question sine of angle A, which is given 3 by 4, and we have to find out the cos of angle A and tan of angle. Okay, what we have to find? Cos of angle A and tan of angle A. Okay, what we want? We want the value for cos of angle A and tan of angle A. Okay, sine of angle A, which is already given. Let me plot the figure first of all, that you all can get the meaning about the angle, which is the possible value. Okay, okay, let me define first of all triangle over here. Okay, so I do have one more triangle. Okay, Now we can see sine of angle A given. So as we have angle A, so let's plot A, B, C as the right angle triangle. Always make sure that if we have to find out the trigonometric ratios for some certain angle, that we cannot consider 90 degree or right angle triangle as the part of our calculation. Okay, so we consider this angle A, entire angle A. Okay, we consider this entire angle A is the part of our calculation now. Okay, and as we know that sine of any angle can be defined as opposite side upon hypotenuse. Okay, so opposite side upon hypotenuse means we write it as the opposite side divided by hypotenuse. Okay, so opposite side we write it as the 3 centimeter and hypotenuse we have 4 centimeter. Now see that how easy question we have. First of all, try to visualize what we have given in our question. Once you come to understand, next part it is easier. Okay, yes, everything is easier later on. First of all, define what we have in our question. Okay, okay, now we have AC which is a 4 centimeter, BC which is a 3 centimeter. So let's apply Pythagoras theorem in order to get the solution. Okay, let's apply Pythagoras theorem, and Pythagoras theorem it says that hypotenuse square, that means AC square, that means AC that side square, hypotenuse square, which is equal to addition for remaining two side square, that means AB square plus BC square. Okay, AB square plus BC square, which is the AC square. Okay, so AC square we know that the 4 centimeter square, which is equal to AB square, keep as it is, plus BC square, which is a 3 square. Okay, yes, 16 minus 9, which is equal to AB square. Okay, so AB square we write it as the 16 minus 9. What is the value for 3 and 4 we have already. Okay, yeah, 16 minus 9 we write it as the 7. Is it the 7? Yeah, it is a 7. Okay, yeah, 16 minus 9, 9 and 7, it is a 16. So AB square, which is a 16, then AB we write square root of a 7. Okay, it is okay if the value it is under square root. Okay, so we write AB which is equal to square root of 7. Okay, so AB is the square root of a 7 centimeter. Let me put this value here, 7 centimeter. Okay, square root of a 7 centimeter. Now it is easier to find out the value for cos and tan. Okay, let me define the value for cos and tan. Okay, okay, now next what we want, the value of a cos of angle A. Cos of angle A, and we know that the cos of angle A can be defined as the adjacent side upon hypotenuse. Okay, so about the angle A, adjacent side it is defined as the AB upon hypotenuse we have AC. Okay, what is the value for AB, which is the root 7? What is the value for AC, which is a 4 centimeter? So AB upon AC, which is a root 7 by 4 centimeter. Okay, which is the actual value for cos of angle A. Okay, cos of angle A. So I got the value for cos of angle A. Let's find out the value for tan of angle A, and we know that the tan of angle A, it can be defined as the opposite side upon adjacent side. Okay, so opposite side means BC upon AB. Okay, so BC upon AB. Okay, so BC upon AB we write it as the AB upon AC. Put this value here, it is a yes, I got the value for cos of angle A. Now we have to find out the tan of angle A. Okay, so which is the root 7 by 4. Now tan of angle A, which is a BC upon AB, so 3 by root 7, 3 by root 7 centimeter. Okay, that's it, the solution. Nothing it is difficult here. It is one of the easiest question and easy solution. I hope you all have understood this solution. Nothing it is difficult here. Even after, if you found anything difficult, let me know in my comment section. Okay, let's go for the next question. In our next question, we have given cot of A, cot of angle A given. Okay, which is a 8 centimeter. Okay, cot of angle A which is given 8 centimeter. Okay, yes, and using the concept of cot of angle A, we have to define remaining concepts. Okay, yeah, let's go for finding the solution. First of all, try to visualize what we have given in our question. Okay, let me pull out the triangle first. Okay, So I do have one right angle triangle, okay, and so let me write angle A here this time because we want some changes ABC, okay. So angle B, obviously it is a right angle triangle. We have to deal the value for angle A, which from angle A, okay, okay. And we know that cot of angle A, okay. How can we define cot? Okay, as we know that tan can be defined as sine upon cos, okay, sine upon cos, or you can directly write their names of the side, okay. Yes. About the tan, we know that we can define as the opposite side upon adjacent side, okay. So cot, you have to go just little opposite of this. So we write adjacent side upon opposite side. Adjacent side upon opposite side, okay. So adjacent side upon opposite side can be written as 8 by 1 centimeter, okay. We can directly write it as the 8 by 1, as we don't have denominator present. So in this case, what we do, we consider denominator as a 1, okay. Yeah, so we do have denominator 1, substitute all these value adjacent side and opposite side with respect to angle A. So we know that the opposite side, which is a 1 centimeter here, adjacent side, which is at 8 centimeter here. Let's find out by using Pythagoras theorem value for hypotenuse, okay. So we write a hypotenuse square by using Pythagoras theorem. Hypotenuse square, which is equal to addition for remaining two side square, okay. So hypotenuse AC square, which is equal to AB plus BC square, okay. AB square plus BC square, okay. So what is the value for AB square, which is a 8 square, plus a BC square, which is a 1 square, okay. 8 square, it is a 64 plus 1 65, which is a CA square, okay. Yeah, CA square, which is a 65. So CA can be written as square root of 65, okay. Don't have option, directly write in under square root, which is a square root of 65, okay. Now it is easier to define of sine of angle A, okay. So easily we can define the remaining values. Sine of angle A, we write it as the opposite, okay. Sine of angle A, we write it as the opposite side divided by hypotenuse, okay. So opposite side we have here CB divided by hypotenuse AC, okay. CB, which is the value having 1 divided by root 65, okay. This one is the actual value for sine of angle A, sine A. Similarly sec A, sec A, we write it as the opposite of a cos A, okay. And we know that cos can be defined as adjacent upon hypotenuse. So hypotenuse upon adjacent we write as the sec, okay. So hypotenuse upon adjacent, that means AC upon BAB, okay. AC upon AB. Put the value for AC, which is a root 65 upon AB, which is a 8, okay. That's it, the value for sine of angle A and sec of angle A, okay. I'm expecting that you all have understood this entire solution. Nothing it is difficult here. Even after, if you found anything difficult, let me know in my comment section, okay. So let's move for the next question. Yeah, in our next question, we have given angle A, angle B are the acute angle triangles such that cos A, cos B are the two trigonometric ratios are equal with the respect of angle A and angle B, okay. Okay, it is obvious proof that you can plot the triangle, you will get the directly proof, okay. So you have to plot the triangle that where angle A and angle B are the acute angle triangle, okay. So you have to plot the two triangles, okay, here angle A and angle B are the acute angle triangle, okay. Yes, and then easily further part you can define it, okay. We know that cos of A, which is equal to cos of B, then obviously if this value and this value gives us the equal answer, obviously we write angle A, which is equal to angle B. This is the obvious proof, but you can prove by your way, okay. Plot the triangle, that is easier to find out the answer here, okay. Yes, it is easier to find out the answer that you can define a triangle, okay. Let's plot the triangle where you get the two angles are right angle triangle, okay. Okay, let me plot first. Okay, another let me plot. with another color. Okay, yes. So I do have triangle. One angle need to be angle B. Okay, one angle A and angle B are right angle triangle. Angle A here, angle B here. Okay, so remaining here B, C, A, C. Okay, so you can define this way. Okay, as we have given angle A and angle B are okay, these are the acute angle, not the right angle. Okay, it's my mistake. Okay, it is not the right angle. I thought it was the right angle. Okay, these are the acute angle triangles, so that we can define in a same triangle here itself. Okay, yes, let me plot the triangle here. All are the acute angle triangle. Okay. Yeah, as you can consider, it is a little. Let me plot another triangle. Yes, this one is our acute angle triangle. Consider it as the acute angle triangle. Okay, yes. So as we have angle A and angle B are acute angle triangle. Okay, we need angle A and angle B the position that they are the acute angle triangle. Okay, yes. Now let me take ABC are the acute angle triangle. Let's define one next line which can divide this one with the third point. Okay. Yes. Then we have to find out the whether angle A and angle B, this gives us the equal value. As you can't understand this one, so you can directly substitute the value for angle A and angle B. So as we can see here, cos of angle A, okay, and cos of angle B, both are equal. So you can consider angle A as a 45 degree, angle B it is a 45 degree. We can see that about these two value, our cos always gives us the equal answer. Okay, that directly you can define, or you can directly go for the finding the value using the triangle where A and B are the acute angle. Okay, and the third point D can divide that line segment AB and apply Pythagoras theorem with keeping that hypotenuse same. Then you can substitute and equate these two hypotenuse, you will get the answer. Okay, keep that proof for your homework. Let me know in my comment section answer. It is 1 or 2 line proof. Nothing it is difficult. I'm expecting that you all have understood this proof. Okay, but I want the proof with a detailed solution. Let me know in my comment section. Okay. Okay, this one is maybe it's our last solution. Okay, yeah. Okay, in our next example, we have given cot of x. Okay, we have given cot of x 7/8 here. Okay, and we have to find out the value for 1 plus sin x upon 1 plus sin x into 1 minus sin x, 1 plus cos x upon 1 plus cos x multiplied by 1 minus cos x. Okay, using this value. Okay, let's find out the value. So here in my question we have given 1 plus sin x multiplied by 1 minus sin x. Okay, divided by 1 plus cos x multiplied by 1 minus 1 plus cos x multiplied by 1 minus cos x. Okay. Okay. So here we easily can define 1 plus cos x upon 1 minus cos x, 1 plus sin x. Okay. So 1 plus sin x multiplied by 1 minus sin x, like a plus b multiplied by a minus b. We write a square minus b square. Okay. So we write 1 square minus sin square x, and 1 plus cos x, 1 minus cos x, we write 1 square minus cos square x. What I have done actually, I written here a plus b multiplied by a minus b as a square minus b square. Okay. Yes, 1 minus sin square, we know that the cos square x. Okay, and 1 minus cos square, we write it as the sin square x. Okay, as we know that sin square x plus cos square x, which is equal to 1. Okay, using this value we can define easily this one here. Cos square x upon sin square x, we know that the cot square x. Okay, and we want this value means we want the cot square x, and we want the next value means cot square x. So both are giving us the equal value. Okay, so we want the cot square x actually. Okay, the value for cot x is the, okay, the value for cot x, which is given 7 by 8. Take the square for both sides. So cot square x can be written as 7 square, which is a 49, 8 square, it is a 64. Okay, this one is our required solution. Okay, I'm expecting that you all have understood this solution. Nothing is difficult. Next question, keep it for your homework. Okay, I'm not gonna explain this one. I'm going to keep this part as the part of your homework. So if you found anything difficult, let me know in my comment section. Okay, let's go for the next question. Next part. This one is our entire lecture that I taken here today. That I wanted to make you familiar with some of the concept in my today's lecture that I done already here. So even after, if you found anything difficult in my today's lecture, let me know in my comment section. Okay. So I hope you all have understood my today's entire lecture. Nothing it is difficult here. We begin our lecture with the topic that different trigonometric ratio with respect to right angle triangle. I define their sine, cosine, tangent, cotangent, secant, cosecant, everything here in my today's lecture. After that, the values for 0 degree to 360 degree I explained here, and at the end I explained some of the example here for you all. Okay. I'm expecting that you all have understood everything from my today's lecture. So I'm expecting everything it is easier here. Even after, if you found anything difficult, let me know in my comment section. So thank you everyone. Thank you for my today's lecture.